Welcome back to Distributed Generation and Smart Grid lecture series. In this coming videos, we are going to discuss about protection issues of microgrid. So, as you all know that a microgrid is an aggregation of electrical or heat load and small capacity on-site micro sources operating as a single controllable unit at the distribution voltage level. Conceptually, a microgrid should not be thought of as a conventional distribution network with additional local generation. In a microgrid, the micro sources have sufficient capacity to supply all the local loads. So, a microgrid can operate both in synchronism with the utility, that is the grid connected mode, and in autonomous power as in a standalone mode. So the operating philosophy is that under normal condition the microgrid would operate in the grid connected mode, but in case of any disturbance in the utility, it would seamlessly disconnect from the utility at the point of common coupling and continue to operate as an island. And this session we review the two major protection issues that must deal with in order to ensure the stable operation of microgrid during any contingency. So these are as follows. To determine at what instance the microgrid should be islanded under specific contingency. And second point is to sectionalize the standalone microgrid and provide the sections with a sufficiently coordinated fault protection. Some of the problems with the inverters, because although the characteristics and performance of the most protection elements of a microgrid are consistent with those present in the utility distribution network, it is not the same for the micro sources, not the same for the micro source power electronics inverter systems because of the following reasons. These are the characteristics of inverter may not be consistent with the existing conventional protection equipment, and different inverter designs have different constant and therefore do not have any uniform characteristics that would represent inverter as a class of equipment. And basic characteristics of inverter unit as seen by the system can change markedly depending upon design and application. And this is a structure of a protection of microgrid. You can see a schematic diagram. Here you can see the utility main grid part and microgrid part. It is there are micro sources. MC is the micro source controller. Each micro source or each local generation are connected through a micro source controller MC. And here also you can see a PCM, which is known as protection coordination module. And in central controller, the main function can be divided as a EMM and PCM in this diagram. EMM is the energy management module and PCM is the protection coordination module. So this figure gives an idea about a general structure of a microgrid with its protective measure. So protection issues of microgrid cannot be properly resolved without uh, thorough understanding of microgrid dynamics before, during, and after islanding. So also the time of islanding in the microgrid should be preceded by a realistic assessment of what benefits the microgrid will gain from the rapid separation. And for if a significant number of microsources have power electronic inverter interfaces, then the transition from grid connected to standalone operation results in a marked reduction in the microgrid fault level. So this actually affects the sensitivity and operation of the overcurrent relays in the system. And if the relays are set for higher fault current in case of a grid connected operation, then the same relays would operate very slowly or may not operate at all for the standalone operation due to the lower fault current. That is, when we are connecting a microsource or microgrid to a grid connected mode, there will be a particular settings for the relay. And if it is a higher value of the fault current, and suppose the microgrid is working or operating in a standalone mode, you cannot expect that much level of fault current. So even if the fault occurs in an islanded microgrid, the relay will not be operating. So very high speed of operation is required, and spurious trips are to be avoided at the same time. So then transfer trip mechanism should be installed between the utility grid substation and PCC circuit breakers. And for secure and reliable operation of standalone microgrid, the protection system should ensure the following. First one is a appropriate grounding must be provided for standalone microgrid. Then fault detection devices in microgrid must work in a compliance with the fault detection system in the grid connected mode. Then third one is a means of fault detection not depend on a large ratio between fault current and maximum load current must be provided to take care of a reduced fault level after islanding. And fourth one is any load shedding scheme set up by the utility in the microgrid area must be closely coordinated. So these are the main functions of any protective system in a microgrid. And another scenario is islanding, that is what is the separation from utility. That is, microgrid normally have a capacity less than 10 MVA, that is very small compared to the utility. So microgrid must have a sufficient generation to supply a significant portion of its load. So if islanding does not occur at the PCC, then microgrid may carry a part of the utility with it. So in this matter, IEEE standard suggests a minimum interconnection protection criteria which a microgrid should meet during the grid connected operation. And cost of implementation and technical limitations are important for designing such protective schemes for microgrid. And these are some of the points or issues should be duly considered for islanding the microgrid. You can see that whether the speed of the operational protection system need to approach the criteria given by SEMI F47 specification. Then second one is how to minimize the spurious separations. The third one is whether non-fault separation would be allowed for under voltage, open phase and voltage unbalance conditions. And fourth one is whether resynchronization to utility would be automatic or manual, particularly in relation to frequency and voltage matching. And also we can consider separation protection limitations imposed by exporting microgrids. So, and different islanding scenarios. That is, whenever when you're dealing with the islanding of microgrid, the following scenarios related to the islanding of microgrid can be uh, discussed. These are fast separation from the faulted feeder. Then second one, prevention of spurious separation. Then third one, non-fault separation. Fourth one is a separation from exporting microgrid. Then resynchronization.